Hello and welcome. This is Aurora with Supercharged Math, and we are early. We are 10 whole minutes early. So I wanted to jump on early and answer a couple of questions that have been coming in that are pretty similar. So I don't know if you know this, but I get about 500 emails-ish a day. So I dedicate 1 to 2 hours just to getting those emails taken care of. And so your questions and what you have questions about is really important. So my team and I spend quite a bit of time answering those. I do spend time on classes ahead of time. Sometimes we'll do games, sometimes we'll do puzzles, sometimes I'll answer questions that are coming in that are really common. And so that's what we're going to do today. We're going to do the third one. Next time we'll play some games and puzzles, and I promise we're going to have a story today. So today is going to be a class in fractions for grades 4, 5, and 6, and we're going to start in about 9 minutes. If you're new to Supercharged Math, hang on here for the next 9 minutes. Let me outline a couple of quick start things for you to get started with the program. If you're feeling the program is overwhelming, you can't find something, you're not quite sure how it works, let's go through it step by step. All right, so students, we're not quite started yet. Get your math journal, get your pencil, and then we can get started. Okay. So very quickly, let's go over to the math program. So I have an online math, I have science too. This is my online math program. It's just specifically math, but it's taught from a science perspective. So what does that mean? Okay, so basically what we're going to be doing is math, but also bridging the gap between how math is useful in the real world. So for example, today we're going to talk about physics in our advanced class when we cover algebra, and we are going to be talking about physics. We're going to talk about projectile motion, elevator drop rides. We're going to talk about throwing things off of cliffs, and then where do we actually see algebra showing up and what does that look like? And so that's going to be in there as well. Okay, so I have a program. It's for grades 4, 5, 6, 7, and 8. And so grades 4, 5, and 6, we cover fractions, decimal, percent. We also have an introduction to geometry as well as a pre-algebra course. And we cycle through all of these in over the course of 1 year. Now that's more than your students can be able to do in a year. So this is a self-paced program. You go at your own pace, on your own schedule. You decide what you want to study, whether it's fractions, decimals, maybe you want to start with geometry. So it's up to you, and then you just dive into that area. You decide how often you want to do math, and then we have more than enough content for your student. If you want to do the live classes with me, which is what we're going to be doing here in just a few minutes, then we take 7 weeks to go through each one of those 5 areas that I just mentioned. That's 35 weeks, that's a full year. So your student won't complete all of fractions in 7 weeks. That's just too much. So instead, what we prefer is that we get you started with the live classes, and then you can do the study on your own once you understand how the program works. If you'd like to keep up with the live classes and just do a multi-subject approach, so you're going to do fractions for a bit, then decimals, then geometry, that works too. Just know that you'll take about 3 years to cover all of these concepts. And we have live classes to support that. We do 2 live classes every week with a 3rd optional live class with a teacher that is a small group private tutoring session. So every week we present a new concept, and that with the teacher, so you can ask your questions and participate live, or you can watch the recording afterwards if you find the teachers talk too fast or it doesn't fit with your schedule. We always post the recordings right after the class, and so you'll have those. You're going to do 2 sessions with a teacher. They're usually between 30 to 60 minutes depending on what we're doing. And then if you find you still would like more help, there's an opportunity to bring your questions from any part of the math program on Friday to our live study hall, and that's another teacher. Her name is Leah, and she runs those. So we have a lot of support for the students. All right, so it's a typical, we use the university model. So the teacher will present the information, and then you work every day and you study. If you just do the live classes and you don't do any of the homework, you're not going to get very far with the program. So you do want to make sure that you are practicing and participating and doing the work that we have outlined for you. We have lots and lots of videos every single week to support that. All right, so I just mentioned grades 4, 5, and 6. What do grades 7 and 8 do? They cover algebra, which includes pre-algebra, and a full Algebra 1 course. There is an algebra-based geometry course that we have. We also have probability and statistics. So there is quite a lot for grades 7 and 8. Again, the algebra course and the geometry course, those are full year courses. And so because we're doing a live schedule, what we are doing is we are teaching algebra over half of a year, and then we move to geometry. And then we circle back the next year, we teach algebra for half of the year, and then we do geometry. If you would like to do a deep dive and just do algebra for the whole year, all that content is up already. You don't have to follow the live class schedule. You do it as at your own pace. So you're kind of getting a feel for how this works? Okay, so for today, for example, here I've got 4 minutes left. So for today, we're going to have a class in fractions first. We'll do fractions. So it's for us, it's week 5. Now, if you've just joined us, you would start with the first session. And they're all outlined here, fractions 1, 2, 3, 4. In the live class, we have 5, and then we're going to have 2 more weeks, 6 and 7. And then we'll have a review and a math party that I'm going to announce today. And then we reset to another area. And that way, students that don't join us right on September 1st, they can still join us for something else. So then we're going to start a decimals unit, and you can start with that as well. Especially if your students are kind of getting burnt out or bored with fractions, you can't possibly imagine them doing fractions for a year. It's also good to have a multi-subject approach, so your student can be thinking about fractions, but then starting something new, because it's always good to have some variety in what we're doing and not just drone on and on and on about the same thing, especially if your students are feeling stuck or struggling with it a little bit more. Let's just put it aside. Let's maybe start some geometry or something different. Okay, so what's going to happen today? So today for class, I am going to deliver a class. It's about 30 to 35-ish minutes. And then I spend a lot of time answering student questions. And then at the end, I'll say, okay, and you'll actually see me do this today. I'll say, okay, so at the end of fractions session number 5, I want you to go to the page, and this is the actual page here, and the parent video is always at the top. This is just for parents so they know exactly what, good morning, hi Diana. So this is the parent video just for parents about what your student's going to cover this week. So students don't usually watch this. And then what they do watch is there is a button. The first button says this is the outline. These are all of the math assignments. And depending on where your student is with what we covered today, you can go to the appropriate level. For example, if the content I'm going to present today, if it's new to your student, they've never seen it before, they need a little bit more time, then what you're going to do is you're at the beginner level. So it just means you're new. That's all. And this can change from week to week, by the way, because I may cover something and your student's like, I already know that. That's easy. But maybe the following week, they're like, never seen that before. So be really flexible. Don't just stick the label on their forehead and say, you're always going to be a beginner. They can actually change from beginner to intermediate, sometimes even within the same class. It just means it's new. And once they've seen it, it's not new, right? So we have workbooks that you can either print out or view and just have them write the answers in a notebook, in a journal. And then that we have step-by-step instructional videos that walk them through the workbook as well. So if they have additional questions or want extra help with me personally walking them through more problems, that's in there too. And then once they've been introduced, they just need more practice, right? We get better at things that we practice. So we have we're going to hit it at different approaches. So for example, today we're going to talk about different operations with fractions. So we are going to attack that from different angles. This is where the puzzles are and the games and the challenges and all of those fun, or not the challenges are last, and the projects and activities are in this area. And so your students sometimes they'll be cutting things out, sometimes they'll be coloring, sometimes they'll be getting lost in mazes, sometimes they're going to be working on like a pyramid puzzle. It depends on what it is. And so there are lots of like task cards and scavenger hunts and treasure hunts and lots of fun stuff in here. And then after they've done the beginner and intermediate level, we want you to go to the next session and do beginner, intermediate, beginner, intermediate, beginner, intermediate, because the advanced section assumes you are already familiar with everything with fractions, but you would like the practical application approach. And I want to say 90% of our families find the advanced level the best part of the entire program. So if you're a beginner, work on your workbooks and then do the intermediate work, and then make sure you get all that done, and then circle back to week 1 and do all the advanced labs, because you don't want to miss out on those. Everything from astrophysics to astronomy. Today we're going to have some in chemistry and physics. So we have a lot of really fun things coming your way. And so if you have a bicycle, you're going to need that for the advanced lab that we're going to announce today, as well as if you have Legos, you're going to need those as well. So we have a lot of hands-on practical application pieces to really bring this math stuff and to life, to show you how it's used in the real world. And then we always have review sessions at the end. We review everything we've done. We also have review sessions midweek, which we had last week. So the students are very supported. It's an incredibly amazing program. It was designed by scientists and engineers, not academics stuck in an office who've never actually taught students before. So, which is where a lot of textbooks come from. So this is so much more than a textbook. This is a real approach to learning math in a way that works. And so at the end of class, I'll go through the website and what all these videos are. But just know there's a ton of videos on the website. In fact, that's why we're taking 2 weeks for every session in algebra for our upper level, just because there's 40 to 50 videos on there, and they're not 2-minute videos. They're between, I want to say 4 and 5 minutes to 45 minutes each. So there's a lot of content for your student to enjoy. Okay, and then if you ever get stuck, that's where you're going to let us know, Aurora at superchargedscience.com, and we are happy to help you with whatever questions you have, because you should not feel stuck or alone with a math program, which unfortunately a lot of textbooks are, right? You ever try to ask a book a question and the book's not really talking to you? Okay, we don't want that to be your experience. We want you to have a happy, positive experience with math because we want you to come back and do more. Yes? All right, yay! And it's right on the nose, 9 o'clock, yay! Shall we begin? Shall we begin? Yes, let's do it. All right, so let's go ahead and do our official start. 3, 2, 1. Hello and welcome. This is Aurora with Supercharged Math. Welcome to session number 5 in fractions. We are going to be diving into our fractions today, and if you have the handout that I prepared for you, grab it. If you don't have it, you don't need it. This is just if you would like a little extra to be able to take notes on. This is new this year. I'm making them week by week, so do let me know how these are working for you. Okay, so grab your pencil, grab your math journal, because I want you to write across the top for today. So you write today's date on it, right? And then across the top, I want you to write this announcement so you don't forget. We have a math party coming up. Do you like parties? Yay! What if it's an Aurora party? Would you come? Okay, yay! So we are going to have a math party. These mark the transition between one math unit and another. So we're wrapping up fractions. We're in week 5. So at the end of week 7, we have a fractions review session. Everyone is invited, even if you're working on a different part of the math program. Next Sunday, I will be sending out an email that has the link that you need to participate in the math party. And it's a special link. It's just one-time use. We're all going to get together. It's going to be super fun. I'll tell you all the details in the email, but just mark your calendars so you can be sure to participate. These are not recorded just because it's live with a whole bunch of kids, and so we're not recording the kids or anything. If you can't make it, we're going to have another one for the next one, which is decimals. We'll have another one for percent. So we will have them throughout the year. You should have an opportunity to join us. Yay! Okay, and shall we begin with fractions? Yes. All right, so for fractions, I have, there we go. So for fractions for today, we're actually going to be talking about a couple of different things. We're going to talk about adding and subtracting fractions, and we're also going to work on some word problems. So we have 2 different things we're going to be working on together. So let's just get to it. Grab your notebook, grab your pencil. If you have a question anytime, you can put it in the chat box that's below this video. If there isn't a chat box, that's what email is for, Aurora at superchargedscience.com. Send me an email anytime during class. I do check it periodically and answer as many of those questions as I can. All right, rev up your engines, rum, rum, rum. Let's get going because you have to earn your story today. Yes, you do. Okay, so we are going to go ahead and get started. So this is the first page, Math Fractions, session number 5. Somebody's asking, where do I find that handout? So that handout is something I sent to you over the weekend. And then also, if you don't have the handout, here, I'm going to grab something noisy here. If you don't have the handout, that's okay. Remember, all you need is a piece of paper to get started. Okay, so this is a handout that also you can find under fraction session number 5, and it's right under the parent video. It says download handout number 5. Okay, but again, I mean, look at how much white space is on there. This is just so you can take notes. Okay, so this is just your note-taking area. Okay, so your handout is 3 pages. So let's go ahead and get started. So let's everyone take a look at mine, even if you don't have yours. Okay, take a look at mine. All right, what do you notice here? What do you notice? I got some fractions, right? I have some fractions. Good. So do you notice how the bottoms they match? See the 3s? All right, so in order to add fractions, the denominators must match. Must match. Okay, so that's gonna, here, let me bring that camera down a little bit. Okay. So if I said 1/3 plus 2/3, do the bottoms match? Yes, they do. So what that means is I am simply going to bring this over. We don't add the bottoms because that wouldn't make any sense. Here, watch. So for this one, 1/3, the 3, remember, talks about how many divisions you have. The 1 is how many actually you're talking about. So this is a pizza sliced into 3 pieces, but you only took 1. Your friend took 2. Okay, so what does that mean? How many pieces altogether? There's 1, 2, 3, or 1 plus 2. So you just add the top. 1 plus 2 is 3. We just keep in mind you don't add the bottom because we don't add the number of divisions. So 3 out of 3 means we're talking about an entire pizza here. Okay, so you could also say this is equal to 1. All right, so this was a quick review. This is what we've been doing so far. But what if they don't match? Okay, so that's what we're going to focus on for today. So if I were to say to you 8 minus 3, what would you tell me? 8 minus 3. Yeah, this is easy, right? You're like, this is not hard, Aurora. Okay, and if I said 8 over 12, okay, what's missing now? Yeah, the divisions, right? Okay, so notice it's the same pattern, right? As long as these two match, then you can just add or subtract the numerator and write it over here, and you just carry the denominator, okay? All right, if I said, let's do one more. 1 plus 4, what would you tell me? 5, right? Good. What if I put them all over a 6? If this is now 1 6 plus 4 6 equals how many? That's right, 5 6. Okay, good so far? Okay, so what if they don't match? I have 2/3 minus 1/4. I want to say this is probably the most challenging part of fractions for people. So let's take it step by step. We're going to find something called least common denominator, LCD, least common denominator. And what that means is you see that 3? Okay, tell me, can you help me count by 3s? Here, I'll write it in another color. 3, then what? 6, 9, 12, 15, right? And it keeps going on, okay? Can you help me count by 4s? Help me count by 4s. 4, and then 4 plus 4 is 8. Okay, 8 plus 4 is 12, then 16, and it goes on. Do you see any that match? Yeah, which ones match? Okay, the 12. All right, so what does that mean? That means that the 12 is the smallest number. There are more out here, actually 3. Eventually you get to a 24, and 4 also has a 24. But we're looking for the least one. L is for least. L-E-A-S-T, least common denominator. So we're looking for the one that's common to both that is the smallest. So the first one that pops up. So 3 goes into 12, 4 goes into 12. That's what we want. Okay, so this may be the confusing part, or it may actually be the easiest part for you. Watch this. If I know that 12 is the least common denominator, it's the thing that both these numbers go into, what do I have to multiply 3 by to get to 12? So here, I'll write it here. 2/3, okay? 3 times something gives me 12. What is it? Yeah, it's times 4, isn't it? So 4. So I can't just multiply the bottom by 4. That'll change the problem. I can multiply top and bottom, right? Because 4 over 4, that's the same as saying 1. So I'm basically multiplying by a clever form of 1, 4 over 4. 1 times 2/3, nobody cares if we multiply 1 times anything all day long. We can do that. Nobody's going to raise a fuss. So let's do it. 4 times 3 is 12. What is 4 times 2? 4 times 2 is 8. So we just scaled up the fraction of 2/3 to be 8/12. So you can see if I divide top and bottom by 4, I'm going to get 2/3. So 2/3 is the same as saying 8/12. So out of every 3 cookies, you eat 2. If there's 12 cookies, that means you ate 8. All right, let's do the same thing for the quarter. Okay, so we'll move this up. So 1/4, what do I have to multiply by to get the bottom equal to 12? Is it 4? No, that'd be too big, right? What do I need to multiply by? That's right, 3. Now, can I just do the bottom, or do I have to do the top too? Yeah, I have to do the top. Okay, in order to multiply this fraction by 1 and not break any rules, I have to multiply top and bottom by the same. Okay, so you tell me, what is 3 times 1? You're like, oh, that is too easy. And 3 times 4 is 12. All right, so the original problem was 2/3 minus 1/4. Okay, So this is going to be 8 over 12 minus 3 over 12. Do you see how the bottoms match now? Oops. Let's get that up there. Okay. Do you see how the bottoms match? All right. So these must match. And if they don't, you have to scale one or both of them up. We scaled both. And then you just do whatever you need to do to the top. This is an 8 minus a 3. 8 minus 3 is 5. And you carry the divisions. Remember, you don't divide or do anything weird with the bottom. Okay? You just keep those in there. All right, so we did it. That's the process of doing this. And if you're like, wow, that took a lot of energy. Well, the first time you do anything, it takes a little longer, right? Okay, so let's practice so we get really good at this. Okay, so the next problem I have looks like this. I have 4 over 7 minus 1/5. What is the smallest number that 7 and 5 both go into with no remainders? Okay, in this case, it's 7 and times 5, right? Because this is 5, 10, 15, 20, 25, 30, 35, okay? So, and 7 doesn't end in a 5 until we get to 35, right? So the smallest denominator here is 35. So what do I have to multiply the bottom by? Okay, so let's work on this one first, okay? So 7 times something gave me 35. Do you remember what it was? 7 times 5. So I'm going to multiply this one by 5 over 5. 5 times 7 is 35. 5 times 4 is what goes on top, the 20. Okay, what do I have to multiply the 5 by, just look over here, to get 35? What do I have to, is it multiplied by 5 over 5? No, it's 7 over 7, isn't it? Because I need 5 times 7 is 35. 1 times 7, this dot is a multiply. 1 times 7 is 7. Do you see how I scaled this one up first and I didn't do anything with the other side yet? And I scaled that one up first. So you're going to take each one in turn, and now you get to do the fun part. Okay, so write down 35 on the bottom, and 20 minus 17, that is 13. And I can't reduce it anymore. 13 is prime, and 35, it doesn't have 13 as a factor. So there's your final answer. All right, let's do this again. Okay, so remember what were the steps? The first thing was you check the bottoms. Okay, the first problem, it looked like this, right? And it didn't match. These denominators did not match. So we looked at each one individually and we scaled it up. So we scaled it up so they would be the same. All right, let's practice that one more time. Actually, let's practice it a lot more times. All right. Here's one, 3 over 5 minus 1/4. All right, we need the least common denominator. All right, least common denominator. So 5, let's count by 5. So we have 5, 10, 15, 20, 25, right? There's been a lot of them. ... Okay, let's count by 4s. 4, 8, 12. This is like the multiplication table. This is why we memorize that thing, okay? Because that makes this easy. Do you see how these are the same? So 20 is our least common denominator we're going to be able to use. And notice it's 5 times 4. Okay? That's not always the case, but it is here. So what did you multiply the 5 by to get 20? What do we multiply the 5 by? What do you think? Yeah, a 4, right? Yeah, don't pay attention over here. Here, if I scoot this over. There we go. Okay, so 4. But the 4, you can't just multiply. Look at me. I did this wrong. You know how we erase permanent marker with a mailing label? That's right. So give me a second. I actually need a couple of them because this was a big mistake. There we go. Okay, so there we go. So what do we multiply the 5 by to get 20? Okay, we multiply top and bottom by the same number, which is 4. 4 times 5 is 20. So it's got to be the same for the top two. What's 4 times 3? 4 times 3 is 12. Good. Okay, this is not a minus sign. That's just there. Okay. And then tell me about this one, the 1/4. What did I multiply the 4 by to get 20? Yeah, 4 times 5 is 20. So you just kind of have to think. The place where we see students making the biggest mistakes here is they will try to do these both at the same time, and they'll get mixed up, and they'll multiply this by 4 over 4, and they'll put a 4 here instead of a 1 times 5, which is a 5. So that's why we want to go slow. Put your hand over it if it's a lot to look at, because this is a lot to look at, right? So just put your hand over it and just do one side and say, okay, I'm going to scale this one up. Okay, and so it's 12 over 20, and then put your hand here. All right, so I'm going to scale this up. It's 5 over 20. So when you try to do 2 at once, that's how we drop minus signs and we swap numbers, and it's a mess. Okay, can you help me with the last part? Yeah, so 12 over 20 minus 5 over 20. Okay, so you know the denominator is going to be the same because you check, they match. 12 minus 5, this is the fun part, right? Yeah, and there is your final answer, which cannot be reduced anymore. That's as far as you can go. All right, so how are you feeling so far? How are you feeling? Is it a little bit like, ooh, this is probably the most intensive, where we're taking lots of things we've been studying and putting them all together. So I want you to go really slow, which is why we are going to spend more time on this week. We actually have 2 classes just in what we're doing here. Okay, so let's keep going so you feel comfortable. Remember, the first step is to check the denominators, and if they don't match, scale each one up, and then you do the original operation, okay? So somebody's asking, why do you have to scale? Why can't you just say 3 minus? Okay, all right, good question. You know, sometimes if you have questions, just try it and see if it makes sense to you. All right, let's say you had 3/5 minus, I think this is what they're asking. And just say 3 minus 1 is 2, 5 minus 4 is 1. So my answer would be 2. All right, does that make logical sense? All right, let's take a look. What does 3/5 mean? 3/5, this is wrong, by the way. Can you write wrong? Let's just investigate it because somebody had a question, okay? 3/5 means there were 5 divisions and you ate 3 of them. All right, so you had that, but now we're gonna subtract a quarter. So basically what we're saying is we are taking this shape minus this shape. Okay, so we're saying I have a piece that big minus a piece that big. And you're telling me, oh yeah, that equals 2. What is 2? 2 is 2 whole pizzas. Clearly, not what you're going to get with this. Okay, so this is wrong. You can't do it that way. The math doesn't work. Yeah, it breaks. So yeah, if you have questions, try it and then see if you can prove it to yourself. Like, yeah, no. Okay, good. Questions are always welcome. All right, so I have another one for you. So that was wrong. Let's do one right. Okay, well, we have 1/9 plus 1/4. All right, common denominator between the two. If you don't know what the common denominator is, or you don't see it off the bat, you can always just multiply these together. What is 9 times 4? Okay, so they don't match, obviously, right? So let's just look at the 1/9. The 1/9, what are you gonna, oh, look at me, I'm already making a mistake. Well, here, I'll just roll with it. Okay, we know the least common denominator, I'm gonna say is 36. Okay, 9 times 4 is 36. How do we get 1/9 to be 36? Okay, I'm gonna multiply it by 4 over 4. Remember, this is 1, 4 over 4 is 1. 1 times 4 is a 4. 9 times 4 is a 36. Okay, let's do the same for the 1/4. 1/4, and then what do I need to multiply 4 by to get 36? Because I want something over 36. Okay, because I want them both to match so I can add them. Okay, so 9. Yes, 9 over 9. Good. 9 times 1 is 9. And 4 times 9 is 36. Good. So now we're just going to add these two. So the 36 is going to, here, I'll write the answer up here so it's bigger. Okay. So the 36 is the denominator. Good, because they match. You can see they both match. And then what is 4 plus 9? That's your top number. Good. So that's your answer. So 1/9 plus 1/4 equals 13/36. Okay, great. All right. Do you want to know kind of a sneaky way to do this? Do you like sneaky ways? Yeah. Okay. It's exactly this is actually a good bridge between the two. Watch this. So what we can do is, do you notice how 9 times 4, we multiplied them together and we got 36? Okay. So there's another way to do this problem. And if I show you, let me show you on a brand new problem. 2/3 plus 3/4. We're going to add those. Now, the bottoms, they don't match, right? Watch this. What is 3 times 4? 12. Okay. So I'm going to have a 12 plus a 12. Good. What is 3 times 3? 3 times 3 is 9. That goes here. What is 4? Let me do it in a different color. 4 times 2. Whoop, I wrote it in the wrong place. Hang on a second. All right, this is an 8. So what did we just do? We scaled up each one. So this is 8 over 12. This one is 9 over 12. And this is my 8, and there's my 9. And then 8 plus 9 is 17. So we're scaling up by the same amount. This is exactly what we did with the one before with 1/9 plus 1/4. All right, so we're basically saying, all right, this one, to get 3 to be 12, I have to multiply top and bottom by this guy, by 4. 4, 2 times 4 is 8, 3 times 4 is 12. And I know 3/4 I have to scale up to be 12, and I'm going to scale it up by the other one. So I'm going to multiply both top and bottom by the bottom here, 9 over 12. Isn't that fun? Here, let's try another one. If you're like, whoa, hang on a minute. Okay, 1/5 minus 1/12. Let's do a subtraction one. What is 5 times 12? 5 times 12. Yeah, this is, don't worry about least common denominator. 5 times 12. What do you think it is? Yeah, did you get 60? Did you get 60? All right, so what you do is you write the bottom down here and then whatever the sign is, okay? And then what you do is you just go, okay, 5 times 1 is a 5, okay? And it's going to be over 60. And a 12 times 1 is a 12 over, and they're going to be over the same thing. So this is, that's the wrong number, wrong color. 12 over 60 minus 5 over 60. So it's the same thing we were just doing, but we're just saying, well, 12, I'm going to multiply it top and bottom. So I have 12 over 60. And the 5, I'm going to multiply it top and bottom. So 1 times 5 is 5. And 5 times 12 is 60. And then 12 minus 5 is 7 over 60. Good. All right, so you can do either way. They're exactly the same method. Exactly the same. So let's make sure this makes sense. You're going to do this one, and then we're going to talk about it. Can you do this one for me? 2/3 minus 1/2. All right, I'll give you about 15, 20 seconds. Go ahead and get a good start on it. Get a good start. Okay. Okay, get a good start. Okay. All right, so what's a number that they both go into? Did you figure that out yet? Yeah, so I would say the least common denominator is 6. Okay, so how did 3 go from 3 to 6 using multiplication? What did I have to do to it? What did I have to do to 3? Yeah, I have to multiply by 2 over 2. Okay, so that's multiplication. 2 times 3 is 6. 2 times 2 is 4. Good. How about this one? What do I have to do to the 2 to make it turn into a 6? Using only multiplication. 2 times 3, right? So top and bottom get multiplied by 3. Here's your 6. 2 times 3 is 6. 1 times 3 is 3. So I have 4 minus 3 is 1, and the 6's carry over. My answer, how'd you do? 1/6. Yay! Can I do that? Yes, you can, because look, 2 times 2 is 4. 3 times 1 is 3. Did you see that? It's the same thing. It's just 2 different ways of thinking about it. So you choose the way that you like best. Yay! All right, great. So we covered in your handout this page and this page. So we were scaling up the fraction, and then we add. And that's what we've been practicing. So you had lots of room to put these down. Yay! All right, so how are you feeling so far? How are you feeling? Yay! I have a question. Do you like to bake? Do you like to bake? I like to bake. I like to bake when it comes out. I really don't like to bake when it comes out like as briquettes or hockey pucks. And yeah, so if it doesn't work, I don't like to bake. But what are your favorite things to bake? Can you type it in right now and tell me? So I made the most incredible, I even printed it out so you could see, the most incredible, this is from Once Upon a Chef, so I will share this recipe, pumpkin bread. It was, and I'm not usually much of a pumpkin bread, banana bread, and I think the secret is it bakes for like an hour and 10 minutes. So this is a recipe that's 100 years old. This was from her grandmother. And so she shares it on her website. So would you like a link? So if you're in a baking mood, and guess what? It's word problem time. Yes, it is. All right, so we're gonna go on a road trip and we are gonna bake. So can you tell me right now where you are? Can you tell me where you are in the United States? So I'm gonna go from me to you. I'm just gonna randomly pick somebody who's typing it in right now, and I'll figure out what the mileage is, and we will use that in our problem. All right, so we're on page number 3. Let me show you on my desk so it's more clear than just me holding it up. We're on page number 3. We are going, oh no, I already put this in from the last time. Never mind. All right, anybody out there from Cleveland, Ohio to Dallas, Texas? Okay, so last time I actually asked people and then I figured it out, but this time, sure. Okay, do you want to just tell me anyway? Maybe I can find a few more because I don't have the calculations done. We're going to do them live. All right, so I put in there Cleveland, Ohio to Dallas, Texas, but let's use yours. All right, so I'm in California. Where are you? Where are you? Can you type it in real quick? All right, so go ahead and do that. And I'm going to assume you have a driver's license. Okay, so you are driving, I am driving. You can tell me what your favorite kind of car is that we are driving. If you did the advanced labs last week, you did the 0 to 60, which we, weren't you, I'm not going to give away the punchline, but were you impressed by how good some of those cars were that you didn't expect, right? Some of them you expected to be bad and they really were bad. But some in terms of gas mileage and how much it would cost you and how long it would take you and the hassle factor. And some of them were like, wow, that's why mom drives that. So, all right, does that give you enough time? So yes, I've been answering questions throughout the class. So if you do have questions, you are typing them in. I will check another time for this. Yes, so Ada, I see your questions right now. Just go ahead and tell me what your questions are. Excellent, okay. Oh, we have a lot of people. So we can go to Kentucky, Michigan, Atlanta, Montana, Illinois, North Carolina, Missouri, Oregon, a lot of North Carolinas, Montana's, a couple of different people, Georgia, Arizona. Ooh, I like this one. All right, so let me stick it in Google right now and find out how far you are from me. Okay, so keep typing it in, and then tell me what we're going to bake, because we have 2 word problems, right? We got 2 word problems. We're going to do 2. And, okay, I have a student here. Let me find out. It's just the mileage that you care about. Okay, it looks like it's 1,150 miles. We're going to need some snacks, so we obviously have to bake. Okay, so let's round it up to 1,200. Okay, 1,200. So we are going 1,200. No way. Look. What? No way. About 1,200. So I love when this happens. Okay. So we are actually going to Montana is where we're going. I picked one of the cities in Montana. So, and it's about the same as my demo here. Perfect. All right. So I'm going to write, because we're going from California, and California is a big state, and we are going to Montana. Okay. So I have about 1,200 miles. All right, so it just happened to be the same. All right, I'm gonna say that you drove part way and I drove part way, okay? So I'm gonna say you drove, let's say, a quarter of the way. You drove a quarter. And I'll drive a little more. I'll drive 2/3. How far do we have to go? All right, so if I say you drove a quarter and I drove 2/3. Okay, so there are 2 ways of doing this. We could take a quarter of 1,200 and a 2/3 of 1,200 and then figure it out, or we could figure out how much more we have to go as a fraction And then just do that conversion once, which I'm in favor of. So in this space here, you're going to write what I'm writing in my big fat marker up here. Okay. So you drove, so here's California, here's Montana. Okay, and you drove, okay, here's there. This is you went a quarter of the way. And then 2/3 is about there. So 2/3 is, so I went from here to there. So 2/3 is 2/3 of the whole black line. Okay, so 2/3 is about there. I kind of eyeballed it, and so I just then shifted it over because you drove a quarter. So the blue line is 2/3, and the red line is 1/4. And the question is, how much is that? Because we're almost there, right? Do we take a bathroom break, or do we just, hit the gas and finish? Okay, so what we're going to do is we want to say this whole distance is 1, right? That's a whole. So I want to know a quarter plus 2/3. How much is this line? Okay, so I have 1/4 plus 2/3. Oh, I need help. Can anybody do that? Oh dear, I'm having trouble. Let's call this help the math teacher. All right, go ahead and get a good start on that. How are you going to add those? And then I'll help you with the last bit. Okay, how are you going to do it? Oh, apparently we're going to Canada now. The Philippines. We're going to the Philippines. Oh, this is fun. I'm seeing now. Kansas City. Okay, love it, love it. Alaska. No, there's a road trip. I would love to drive to Alaska. I think that would be really fun. Okay, I'm going to do mine off camera while you're doing yours, okay? And then you tell me what you multiplied by, and then what they add together to make. Okay, are you ready? 3, 2, 1. Did you get the common denominator is 12? Yep. And then I multiplied this side by 3/3, this side by 4/4. Okay, good. And then, would you agree with my answer, or did I make a mistake? Would you agree, or did I make a mistake? Take a look. Okay, so go ahead and take a look. Okay, all right, yeah. So it's 11/12, and then what happens? Okay, so that means this line from here to there, this little tick mark is 11/12. You tell me, how much more do we have to go? Well, if the full thing is 1, so basically, can you see we only have 1/12 to go? How did we do that? Because we have 1, which is the whole thing, minus 11/12. And remember what 1 is. Here, we'll extend the paper here. 1 is the same as saying 12/12. Right, that's 1. And then we're going to subtract how much we've already driven. So the bottoms are the same, 12, right? Because that's the definition of 1. So this was 1. So 12 minus 11 is 1. So we have 1/12 to go. Yay! Okay, great. How many miles is that? How many miles is that? Okay, and this is where it can get messy, especially if it was like 850. But you can still do it. So what we're going to do is we're going to take how many miles we went, and then 1,200 miles, and we say, well, how much is 1/12 of 1,200? Because from here to here, it's 1 unit. That whole unit here, this is 1,200 miles. This is on the map. Okay, I want to know how much is this? So 1,200 divided by 12, can you do that in your head? Right? 12 times 100 gives you 1,200. So this is equal to, we only have 100 miles to go. And if you're driving a Ferrari, we can get there in an hour, right? But if you're trying not to get a speeding ticket, yeah, it's going to take us maybe an hour and a half, hour and 40 minutes to get there. Yay! So this part here, this is 100 miles. That's how much we have to go. Yay! All right, we made it. So we're at your house. And of course, I brought the chocolate chips. And I also brought the recipe. And we're going to bake. Yes? All right, let's hop over to the last one. Baking, baking, baking. Okay, so we're gonna bake cookies. So we're in person, right? We're in person. We're gonna bake some cookies. You bake, let's see, you guys gave me a whole bunch of ideas for cookies. A lot of people like chocolate chip, and somebody very specifically say absolutely no nuts ever. Okay. All right, we had a couple of snickerdoodles in there too. Pumpkin cookies with chocolate, yum. All right, so let's bake, what's a good number for baking? How about 200 cookies? You guys wanna make 200 cookies? Let's do it, 200 cookies. Aurora eats, let's see, how hungry am I? I'm gonna eat 20, okay? And then you're gonna go over to Doug and say, Doug, I'm gonna give you a fifth of the cookies, and you're gonna give half of the cookies to Leah. Okay, how much, is there any left for you, or did you give them all away? Ooh, let's find out. Okay, so if I ate 20, so this is out of 200, I ate 20, out of 200, a fifth you gave to Doug, out of 200, half you gave to Leah. Okay, so these don't match. Look, whole number, fraction, and they mean something different. This doesn't mean you get a fifth of a cookie to Doug. This means you gave 1/5 of 200 to Doug. So this is all mixed up. These aren't the same. So let's make them the same. Because these two are fractions, let's just convert my 20 cookies to a fraction. So if I eat 20 out of 200, can you help me reduce this fraction? Yeah, so I can divide the top and bottom, say, by 10. That would give, let's see, 2 over 20. I can also divide the top and bottom by 2. What number do I get there? 2 divided by 2 is 1. 20 divided by 2 is 10. So I ate 1/10 of the cookies. Okay, so 20 is the same, 20 out of 200 is the same as 1/10. Okay, so now, would you agree that all we have to do is add up how much you gave away to find out how many you have left? Yeah, that makes logical sense, right? Okay, so how many did you give away? So I went in and ate 1/10. You gave Doug a fifth of all the cookies. You gave Leah, because you really like her classes, she got half. Lucky. Man, I need to be Leah. Okay, so can I add 3 fractions that don't match? Absolutely. Okay, so what is a number that all 3 of the bottoms go into without any remainder? Okay, can you see that this is 10, 20, 30, 40? Okay, this is 5, 10, 15, 20. Okay, so 10 so far. What about this one? 2, 4, 6, 8, 10, 12. So 10 is common to all 3 of these, right? If you look at the multiplication table, right? You're going to see 10 show up in the 10s, the 5, and the 2. So let's do that. So this is already 1/10, so we don't have to touch that. But we do have to touch this one. So this is going to be 1/5. What do I have to multiply by to get the 5 into a 10? Yeah, we multiply by 2. So I'm going to do the same top and bottom. Okay, do you see how this is going to be a 10 on the bottom after we do the multiplication? Okay. And then let's just write down a half. And then what do I need to multiply the 2 by to get 10? Because we want each of these to be 10. My least common denominator is 10. Okay. Yeah, so I'm going to have to multiply by 5. So do that same top and bottom. Okay, so let's do the multiplication. So 1 over 10, do it step by step. This thing is going to be 1 times 2, which is 2. 5 times 2, which is 10. Do you see just that one right there? Okay, so I can scale up 1/5. I can multiply top and bottom by 2, and then I get 2/10. Okay, good. And then let's just look at this one. Okay, so 1 times 5 is 5. 2 times 5 is 10. Do you see how the bottoms all match now? Now we can just add them up. So I have a 1 plus a 2 plus a 3. Not 3. Look at me. 1 plus 2 is 3. 3 plus 5 is 8. And then we don't add the bottoms, we just carry them over. So that's how many cookies you gave away. So you, out of every 10, you give away 8. But you have, look here, it doesn't say what fraction is left. It says how many do you have left to eat. If you put down 8/10, that sounds like you have not a whole cookie, but like that much of it, right? Yeah, that's not what we're saying here. So 8/10 is 8/10 of 200. So what we want to do is say this is 8 tenths of 200 cookies. Now for us, when we see the word of, that's going to be the multiply symbol. Okay, so this is going to be 8 over 10, and we're going to multiply a fraction by a whole number. And remember, in order to do that, you can have a 1 here anytime you want it. Remember, 200 over 1? So the denominator is always a 1 on a whole number. So let's do the top. 8 times 200, and the bottom is 10 times 1. You can add these up. That's a big number. Or, look, 200 is 20 times 10. Do you see anything you could cancel? Yeah, how about this and this? What do I get? So now I have an 8 times a 20. 8 times a 20. Okay, and how much is, let's see, 8 out of, we're calculating how many cookies got eaten. Okay, yeah, let's just finish. Okay, so 8 out of 10 of 200. Okay, so 8 times, what's 8 times 2? 16. Add a 0. I have 160 cookies you gave away. How many do you get to eat? Well, if you gave away 8 out of 10, you have 2 out of 10 still left, right? Because 8 out of 10 is, let's see, another piece of paper. 10 out of 10 is how many you had? That's 1. 1, that's the whole unit. And you gave away 8 out of 10. So I am left with 2 out of 10 cookies, which is this. So 2 out of 10 times 200. Okay, remember this is still 2 times 10, 20 times 10. I can cross off the tens, and that's a 1. So 2 times 20 gives me 40. So you can eat 40 cookies now. You can eat twice as many as I did. Yum! There you go. So how's that? Yay! Anybody hungry for a cookie? Yay! We did it! We did a lot today. If you think about all the things that we did, so we did 2 word problems. We also learned about how to scale fractions up and down. And then we learned about least common denominator. So there's a lot in here. So if you're feeling like, okay, Aurora, that was a lot to do in one class, you're right. So if you're feeling like that was a lot, what I want you to do right now is you're going to go to the math website, which is here, and you are going to start on fractions session number 5, which is, let's see if you can see this. Fractions session number 5. Okay, the parent video is at the top. You don't need that. Okay, do you see where it says beginner level math class? What you're going to do is, this is if you would like me to work through more problems that are different from today, you can watch, it says day 1 beginner. There's an extra 25 minutes of me step by step going through and more instruction on exactly what we did. And if you're feeling like, yeah, you know, I'm a beginner, but I don't need that. Okay, then I want you to scroll down and I want you to start your workbook. You're going to do workbook pages 17 to 39. And there is a step-by-step video that's about 50 minutes long of me walking through every part of that workbook. And so there is a math assignments outline. Go back up to the top. I should have pointed this out. It's right underneath the parent video. Okay, and math assignments outline is here. If you're a beginner, if you're like, woo, that was plenty, don't give me any more, you're going to do the 2 beginner assignments. The first one is the workbook, pages 17, actually to 41, because you're going to take the two-page test at the end. And then there's also a measurement, you're going to learn how to measure curves. And so we're going to do a little practical, fun little lab with you there. If this was kind of a review and you got this, but you need more practice, we have some really fun things for you. We actually going to have a fractions fair. This is different than the math fair that we're doing for the next couple of weeks. Fractions fair is it's a packet that you download and you work through. It's similar to the bakery and the pizza place and the ice cream workshop. There's a fractions fair. So we're going to the fair using fractions. It's going to be fun. And then we also have a lab for you. Do you have Legos? If you do, you're going to pull them out because there is a Lego gear lab. You're going to be making different gearboxes. We're going to talk about different ratios. We're going to talk about fractions. We're going to take it even further than what we had done today. So there is a gear lab that really does use, and you'll see me in the videos putting together the Legos. And then we also have a bingo game and that uses the same cards as spoons. So if you still have those from a previous session, grab those. And we also have a board game where you can add and subtract fractions. It's just more practice. And then let me show you in the let me show you other things that we have this week. We also have the mini math fair that we are running for the next couple of weeks. So we talked about this more last session. It's at the very bottom of the page, and to find out more about how you can participate, just remember you get a triple entry when you do this for the math prize drawing that we have periodically from time to time throughout the year. And so we just want to help people learn and appreciate math and have a good time with it. And so I want your help. You get to design activity, and there's all kinds of details in there about that. Okay, and then the other labs we have, here's the Lego Gear Lab. You can actually see me actually show you what kind of gear trains to build. And so that's super fun. If your parents have a lot of paperwork, this is kind of a fun lab where you actually get to tell them using ratios to estimate things you don't really want to count, like how many papers is in that stack. You'll be able to say, Mom, that is 3,500 pages. I think you're working too hard. You need to put that aside and go play with me. All right, so so things you don't want to count, how do you handle it? There's also a number of astronomy labs we have for the advanced students. If you already, fractions is old hat and you just want to do the labs, that's great. Make sure that you've completed the beginner and intermediate sections before you dive into these. We are looking at all kinds of things about Saturn and Pluto and a matter of timing. And so we have to work out when the planets line up, because people get excited about that. How do we figure that out? And we're also going to take a look at a galaxy and do some galactic calculations. And if you have a bicycle, you're going to hop on it today, because there is an advanced lab in gear ratios of your bike. And so I will show you step by step how to make a data table and how to record the different gear ratios. And you're going to tell me how well that bike performs, which gears you're going to be going uphill, downhill. And so again, this is practical application of what we are learning about in class, which is super fun. All right, how was that? Yay! I owe you a story. I know, I'm trying to answer all these questions at the same time. Okay, so story. All right, so once upon a time, there was a math teacher who decided it would be a really, really good idea to teach her kids about fractions. Now, I already told you the part about the students that really, really didn't want to do any. Remember, I had to bring in the chocolate chips and this was like a story I think I shared the first 1 or 2 weeks. It was this class that really didn't want to learn anything ever at all, like ever. So, so imagine now we've had a class or two with me, but they're still not really sure about who this Aurora person is. Okay, so I decide that, here, let me make this full screen. So I decide we're going to start, the parents are excited, they're happy, but they're like, Aurora, shouldn't they be learning something other than just math and science? Like there's reading and writing. And I was like, oh yeah, you're right. We should probably learn something else. I was an interim teacher. I was only supposed to be there for a week or two. So it wasn't like I didn't know how to teach. It just wasn't my job. So I walk in and I say, okay, so students, what I want you to do is, I said, we are going to write today. And of course they howled and started screaming. And I think 2 kids actually got up and left. And so this is like the worst behaved class you can possibly imagine. So I had brought in, it's over there on the wall. I didn't bring it over. I said, hey, I won an award. And this award is, I'll reach up and grab it in a second. And I said, this is called 55 Fiction. And if you can, see if you can write a story, but if it's more than 55 words, it gets disqualified. And you can only have 7 words for the title, 55 words or less for the body. And I said, we're just going to spend a few minutes on this, and it could be any story, it could be about anything you want. And so some of the kids were like, okay. And I said, and we're going to turn them into the local newspaper, because our newspaper is the one in our town that does it for worldwide. People send submissions in all year long, and they get thousands and thousands of entries. And if you win, they publish you in the newspaper. All right. So so most of them are like, I think there's a trick in here somewhere, but I don't know where it is. So I was like, I'm going to do it too. And I said, and I did this one year and I won. And so they had printed mine with a picture and everything. So, and that's the one I'll show you in a second. And so, so the students are like, well, okay, it's only 55 words. And then the first thing they start thinking about is, well, how much is that? So they start writing. And then it's so funny. I didn't say anything. I had some music going. I had a few snacks out, right? Because they needed it. So they just couldn't handle writing at all. So eventually there was even a student in there it was a 4, 5, 6 combo class, but there was also a student who was only operating at a first grade level. He got into it too. And so it was really interesting because it was an assignment that everybody could participate in, even the students that were like ahead of the class and so forth. All right, so I didn't say anything else. I said, I'm gonna work on mine over here. If you need me, I'll be here, right? Like just stay out of their way. So pretty soon I'm starting to hear, grumbling. And I'm hearing it, and I'm like, are you guys okay? What's going on? And they're like, my word, there's too many words. I can't, I need more words. I'm like, well, those are the rules. I didn't make them. It's the newspaper's rules. That's why it's called 55 fiction. So they're like, I hear lots of scratch outs and erasing and paper ripping because they're erasing so hard and they're mad at the paper. Long story short, we eventually turned them in. I had a big stack of them. The newspaper published a few of them. It was super exciting for the students. But the night I gave the assignment, the parents called me up because I wasn't one of the parents at the school too. And they called me up and they're like, Aurora, what did you do to my daughter? And I'm like, what's wrong? Like, what did I do? I'm so sorry. And they said, I have not seen her write in 1.5 years. And the mom was almost crying. And she says, my daughter says, don't bother me, Mom. I have to finish this assignment. I am writing and please don't bother me. And she's like, I don't know what you did to her. And then the other one was a set of, I think it was twins, that they had written, and the kids were like one-upping each other, and they're like, I got 55. Well, I only did 54. And they're like, arr! And so they were trying to like race each other to see who could like get the least number of words on the page, but to still have the story. And the next, I think I made it due at the end of the week, and the parents were like, that was such a hard assignment. I was like, really? Because I figured they would like it because they wouldn't have to do very much, right? So anyway, so if you want to participate, you send it into, it's called the New Times, Times, like new, like brand new, New Times, and they publish it in July. And so you can find out all the rules and so forth, and you can do that on there. I'll get up and show you this, and that'll be the last thing we do. But wasn't that fun? So why did these students, that's a good question. Why did they suddenly want to write? Because we made it practical. We made it something real, something kind of fun that was interesting, something that kind of got their wheels going, like, I wonder if I can do that. Yeah? And then also someone who's done it before. So here, I'm going to get up, and I will show you the one I've got. It's over here. And I wrote one, you're going to laugh because this is so like me. What do you think the subject of mine was? Airplanes. So this is the one, I actually framed it, and this is the paper airplane. And so this is the one that won 1 year. So yay! And I actually got a color photo from this is the newspaper clipping. So I had done that as well. So yay! There you go! So that class started to learn, right? Without actually learning, without knowing it. Okay. One other thing I wanted to mention, there's always one more thing. If you, as we go through fractions, if you're starting to get like a little confused, like, oh, what do I do if they're not the same denominator, or if I want to subtract or multiply, there is a operations with fractions wheel. And so it doesn't actually turn, it just is in the shape of a wheel. And so if you're, for example, you want to do addition, you would pull this one down and it would give you the definition of what to do, and then there's a sample problem. And so this is like a quick reference sheet you can put like maybe in the front if you need that. We have these for the decimals and percent and so forth. And so you can print those out and color it if you want. So that's an activity that's in there too. I think that's in fraction session number 6. I think that's next week's session. So you can take a look at that. I know you guys like the 55 fiction one. All right, the fraction skills link isn't working. Skills link, can you tell me can you send me an email with the URL or a screenshot so I can see? If there's something that's not right, then I want to make sure that we fix it. Okay, yay! The competition is called 55 Fiction, 55 Fiction. And so, yeah, super fun. This is yet another story of that runaway class that was just a nightmare, and how they turned around in 4.5 months, and they were the top performing class in the entire school. Yes, and it was so much fun. So, all right, I hope this was fun. If you have questions that didn't get answered, please let me know, Aurora at superchargedscience.com. I hope this has been fun for you, and we are going to continue with this topic for the rest of this week. Doug's going to have 60 whole minutes on Wednesday for your class time, and then Leah's going to be answering any and all questions about any part of the math program that you have, so make sure you take advantage of her study hall on Friday if you need it. There are lots and lots of videos of me working a lot of sample problems with you. If you want more help, remember there's additional class time that's already pre-recorded. You can watch that as well. All right, thank you. I will see you soon. Bye-bye.